Today's topic is sorting, right? So we will be covering this bubble sort, selection sort, insertion sort, merge, and quick, right? So let's start with the first one, that is bubble sort. So the definition is, the idea is basically we will repeatedly swap adjacent elements if they are in the wrong order, right? So let's see this example. Okay, we are given this array 5, 6, 1 and 3, right? Now in the first reversal, what we will do, we will compare these elements. If they are in wrong order or right, they are in right order, correct? Then we will compare these two adjacent elements. They are in the wrong order, right? So we will swap them. We will swap them. So 1 will come here and 6 will come here, right? So after swapping, 1 will come here, 6 will come here. Now we will check these elements, adjacent elements. Now the order is wrong, right? Again we will swap. The order will be now 3. Let's write it with this pen. 3 and 6. Okay, so this is the first traversal, first step we can say. Okay, now the next step, again we will compare the adjacent elements. Okay, now 5 and 1, is it correct or wrong? It's wrong, right? So we will swap them. 1 will come here, 5 will come here. Again we will compare, they are in wrong order or right? It's wrong. We will swap. Okay, 3 will come here, 5 will come here, right? Again we will compare these two elements. It's in right or wrong? It's in right. So in the first reversal only, the last element will be in the correct position, right? So after first reversal, this last element will be in the right position. That means this is the sorted, right? So you can see here it's green. This is the sorted element. Okay, so we will traverse till here. Okay, so this is the second traversal. Okay, after this 5 will be in the sorted array. Okay, so now these last two elements are in sorted array. Okay, now it will compare these two elements. These are in the correct form, right, or the order. So this is the basically the resultant, the sorted form. Okay, so what we are doing, basically we are using nested loop, right? The for loop under for loop, and within this for loop, this is the one traversal. Okay, and after that it will go to this for loop again. It will call these traversals, right? You got it? So what we are doing, we are traversing from 0 to n-1, and we are swapping if array I is greater than I plus 1, right? If they are in the wrong order, then we will swap it. Okay, so I hope you got the logic. This is the first iteration, basically the nested loop. Okay, nested loop, and we will be having the outer loop for these iterations, right? Like this is the first traversal, and for the second traversal we will be having the loop, correct, for all these steps. This is for the steps. Okay, this is basically one step, and these are the traversals. Okay, so shall we write the code? Basically what we are doing, we are comparing the adjacent elements and we are swapping them, and we are doing this basically till all the elements are sorted, right? In the first step, this last element is sorted. In the next step, the second is sorted, right? And so on. Okay, then let's write the code for this bubble sort. So let's say public void bubble sort, and we will be given one array. Now let's take n as the size of this array, and now we will be having for loop, the outer loop, right? The steps So I will start from 0 till n minus 1, correct, and I plus plus. After that we will be having one nested loop, that is j equal to 0, but till when it will run? It will run till n minus I minus 1. Why? Because after each step our last element is sorted, right? If you see this, in the first iteration this 6 got sorted, in the second iteration this 5 got sorted. Basically after let's say I iteration, the last I elements are sorted. So we will check for the remaining elements, right? So that's it. After that we are comparing if array of j is greater than array of j plus 1, right? That means we need to swap them. Int temp, and we will be swapping using third element array j. Array j will be array j plus 1, j plus 1, and array j plus 1 will be array of j, not array of j temp, right? So we are swapping it, and see, we need to maintain a variable. That means we will be checking if our elements got swapped or not, right? Because for the last, let's say here in the third iteration only we got our array sorted. That means no swapping was there, right? No swapping was there. That means our array is sorted. So we will stop here. Okay. So how we will check? We will maintain a variable that will check if we are swapping the elements or not. If not, that means our array is sorted. Now we can return it. Okay. So we will be maintaining one. Let's say here boolean swap. Okay. And here this is basically one step. Okay, swap will be false for this step. Again, these are the iterations we are doing, right? We are comparing the adjacent elements and we are swapping them. If we are performing any swapping, then we will say swap is true, right? And at the last we will check if swap is false, that means nothing is swapped, that means our array is sorted and we can break. Okay, so that's it. This is the bubble sort, right? What we are doing here, see, we are having this let me explain that. Okay, see what we are doing, we are having this nested for loops, right? This is basically for the steps. Okay, this is basically one step, two step, and within this step we are comparing all adjacent elements, right? If something is in the wrong order, then we are swapping this, right? We are swapping the elements, and after this one step our last element will be in the sorted form, right? So let's write it here. After I step, our last I elements will be in sorted form. Got it? So basically what we are doing, we are traversing it, we are comparing the adjacent elements. If they are in the wrong order, we are simply swapping this that elements, and at the last the element will be in the sorted form, right? After each step. Got it? Okay. For compiling we need to, let's say int arr will be 1 2 3 or 4 7 10 2 3. Then we will call this bubble sort, passing ARR. Outside the class. Okay, sorry. It's sorted. Okay, so let's move to the second was selection sort. Okay, so in this what we will do, the idea is we will find the minimum element and move it to the correct position. Okay, so basically this array is given, that is 64, 25, 12, 22 and 11. We will find the smallest element, right? Currently we will be at this point and we will find the smallest element. In this case it's 11, right? So we will swap them, right? We will swap the minimum element with the current element. So after swapping it will be 11 and 64, right? In the next step also we will compare. We will be here and we will be finding the smallest element, that is 12. Now we will again swap this, right? Again swap this. It will be 12 here and 25 here, right? In the next step again we will be finding the minimum on the remaining array and we will swap it, right? It will swap with 22. 22 will come here, 25 will come here. Now again it will check with this. This is the smallest from the remaining, so this is the sorted array. Got it? Sorted array. Now how we will do this? See, we need to find the minimum from I plus 1 to n minus 1, right? So and we need to swap it, simple, right? So we will be having one for loop that will be running from int I equal to 0 till I less than n minus 1, right? And I plus plus. After that, see, currently we are here I. Again we need to find the minimum element from the remaining array. So we will be having one more for loop, right? Let's say int j, that will run from I plus 1, right? From the remaining array. And j is less than n minus 1 and j plus plus, right? Not n minus 1, or let's say equal to, okay. So it's less than n, right? And it is n minus 1 because at the end when it will reach the end, one element should be there for the comparison, right? So we will check. We will find the minimum element from the remaining and then we will swap this. We will be swapping using third element, that is temp. Got it, everyone? So bubble sort, let's say this is selection, right? Selection sort. We are given the array. We will be having n, then boolean is not needed here, we can remove this. After that 1 and till n minus 1, remove this. Swap, we can remove this part also. We will be having one min index, that will be initially I, and then we will be finding the minimum, right? So in the if condition it will be starting from I plus 1, got it, and running till n. And we are comparing with what? Array of min index, right? If we find the smaller element, then we need to update this. If at any point this array of j is smaller than the minimum index, then we need to update the minimum index. Minimum index will be what? Will be j now, right? So after that After that, not here, after the for loop, what we need to do, we need to swap, right? Int temp equal to array of min index with what? Array of I, right? Array of min index will be array of I, and array of I will be temp, right? So it's simple, right? What we are doing, we are finding minimum index from remaining array and updating the minimum index. After that, swapping the current element, and this thing we are doing till the basically till I reach the end, right? Here what we are doing, we are having the array, right? This was the array, and for with each step we are basically putting the minimum element at the front, right? And then we are swapping this, and this will go to the till this index I reach the last index, right? Everything fine. N minus 1 and I plus 1. Let's run this. Bubble sort. Okay. Selection sort. It's sorted, right? It's run time. Okay. Third one, that is the insertion sort. So in this, what we are doing, basically we are building a sorted array, right? Let's see the example. We will select the element. Let's say we are at 12. Then we will compare the other elements, right? Here it's 11. Then we will swap this, right? This is the basically the smaller element. Then we will swap this, right, with the this current element, right? So in the next pass, it will, let's write the array once. 12, 11, 13, 5 and 6. This was the array. In the first step, it will swap this, right? So it will be 11 here, right? 11 here and 12 here, right? In the next step, it will check with 13. Is it sorted? Yes, it's sorted. Again, it will go to this 5. Now it will check. This is the element. It will check with this element. It's smaller, right? It's smaller. So it will come here. Again, it will check with this element. Is it smaller? 5 is smaller. It will come to this point. Again, it will check. If this is smaller, yes, it's smaller. It will come to this point. And within the, with this, 11 will come here, 12 will come here, 13 will come here, right? So what we are doing, basically some while loop will be there, right, for checking the previous elements, right? While loop will be there, in which we will be checking what? Array of, let's say j is the index, till if it's greater than what? The key, right? Key is 5. If it's greater, then what we are doing? We are swapping the elements, right? We will basically, let's say this 13 is at j, right? Then j plus 1 will be 13, right? So 13 will come here, right, at the place of 5 at plus 1 index. So we are doing array of j plus 1 will be array of j, right? And we will do j minus minus. This is the while loop for basically, it will do what? It will ensure that our right side is sorted, correct, after each step. So basically we are taking one element as the key and we are putting this on its correct position on the left side, right? So that it will be, the left side will be sorted. So we are comparing with 13, it's smaller. Then we are comparing with 12, it's smaller. 11, it's smaller, right? So for this checking we will be using while loop, and within while loop we are swapping the elements, right? Basically at the place of j plus 1, this j element will come, right? Here it will come, this element will come here, this element will come here. Got it? So this thing will again run how many times? This is the first pass, this is the third pass, there will be second pass also, right? In which it will be comparing this part, right? 11 and 13. Sorry, it will be 12 here, it will be 11 here, 12 and 13, right? So this is the thing. So again we will be having nested for loops, right? One for loop for these passes, right? I equal to 0 till I less than n passes. Okay, within pass what we are doing? We are basically traversing this, finding the element, and we are finding the right place for this on the left side, such that our left array should be sorted. So this while loop will come here, right? The simple thing, like we are taking a key. Let's see the steps. Assuming array 0 is sorted, right? Then take array I as the key and insert it into the sorted left part at correct position, right? What we are doing here, correct? So this will go till for all the elements, right? So let's code it. Let's code it then. So we will be having one while loop, for loop that will start from 1, assuming array 0 is sorted, right? So we will be checking the current element with the last elements, right? So key will be there. Key will be this array of I, right? Array of I, and it will run till n only. After that, one j will while loop will be there, right? Let's clear this part. Int j, that is I minus 1, right? The last element, and while loop will be there. The condition was if while array j is greater than key, right? Means the last element is greater than the key. That means this is not the correct order. We need to swap this or change the order, right? So first let's check this j should be greater than equal to 0, right? This is the base condition. The second condition was array of j if this is greater than what? The key. That means this is not the sorted. So we will move this key on the left, right? So array j plus 1 will be array of j, right? What we are doing here, this 13 will come here, right? And 5 will come here, like we did here. 5 come here, 13 will come here, 5 will go here, 12 will go here, right? So this was 13 was at, let's say, j, and 5 was at j plus 1. So j plus 1 will be now 13, correct? So basically the last element will go to the plus 1 index till this is smaller, right? After that j minus minus. After that, at the end what we will do? We will do array j plus 1 equal to key, right? We need to update the key also. Got it? Okay, can you repeat it once again? Sure, why not? See what we are doing here. Let's see this example. This was the array, right? 11, 12, 13, 5, and key was 5, right? Now it will compare with the last element, right? We need to find the correct position for this 5 so that this left side should be sorted, correct? Now it will compare with 13. It's smaller, right? It's smaller, so it will go into the while loop. Till when? Till the elements are greater than this, right? So let's say it will compare with this. So 5 will come here, 13 will go here, correct? So 13, let's say 13 was at j index, right? Now what is the new index for 13? It will be j plus 1, right? This 13 moved 1 index ahead, correct? Again it will compare with 12. Again it will move array j plus 1. This is the j plus 1. This was j, right? J plus 1 will be equal to the array of j, right? It will be 12 here now. Again same with the 11, because this is smaller than this is greater than 5, so it will come here. So we are applying this while loop, and within while loop till the elements are greater, it will apply this formula. That means array of j plus 1 will be equal to the last element, right? The last elements are going one step ahead. Understood now? Okay, it's clear then. We can run this. This is insertion sort. It's sorted, right? So this is clear for all. What is the time complexity here? Yeah, it's n square, correct? But in the best case it can be on. Let's say everything is sorted, so within one traversal we will go to the end. That means everything is sorted. Let's move to the next then. Merge, sort. This is important. In this we will be using recursion. Okay. So what is merge, sort? So the idea is divide and conquer, then merge. We need to divide the array, sort each part, merge them, right? 3 parts are there. First divide them, sort them, and merge them, right? If you see this diagram, right, what is happening here? We were having this array 38, 27, 43, 10. Till this point we are dividing this, right? We are dividing this array into the two halves, 38, 27 and 43, 10. Again we are dividing into the two halves, so it's n by 2 now, it's n by 4 now, correct? So 38, 27, 43, 10. Now we will merge them, right? When single element is there, like we can't divide it further, then we will merge them, right? While merging we will check which is the smaller element. We will merge them according to the order, right? 27, 38, 10, 43. After that we will merge these two sorted arrays, right? Sorted array, these are sorted, right? So 3 steps are there. First is divide, second is sort, and merge. Okay, for divide we will be using recursion, right? How? Let's see. So we were having 38, 27, 43, 10, right? This was the array. There is one left, one right pointer, correct? How can we divide this? We need to divide it from the mid, right? This is the mid, this is the mid, right? So we will call the recursion function. We will find the mid element, left plus right, or right minus jo bhi hai, divided by 2, right? We will get the mid element. After that new array will be this thing and this thing, right? So we will be calling the same function, that is merge. Let's say and here the new array is the left and till mid, right? And what is the second array? Second array will be from mid to right, mid to right, correct? So now it will call the same function for this array and this array, right? So first it will call for this array, again it will divide it, right? 38. What is the mid element for this? 38 and 27. It will be 38, right? 38 is the mid element. Again it will divide it. It will call the same function from left to mid, that is 38 only, and from mid to right, that is 27, right? Now after this we can't divide it further, right? So we will call a function, let's say merge the array. Okay, merge arrays, and we will be passing what? The left, the mid and the right index. Okay, let me write the code first for this. Okay, so we are given the merge sort. This is the recursive function, and we will be having one left pointer, one right pointer, that is the array's left and the right pointer, correct? Now within this we will be having one condition, that is right left should be less than right. That means this is the valid array, correct? After that we will be calculating the mid, that will be equal to left plus right minus left divided by 2. Got it? We are calculating the midpoint of the array. After that we will call this same function, that is merge sort, with the new array. With what? Array will be same. What are the new pointers for this new array? From left to mid, correct? And from mid plus 1 to what? The right. Got it? We are having two arrays. These are the two arrays, one from left to right and one from left to mid and from mid to right. Got it? We are basically calling the recursive function. Okay, what it will do? See, at the last what we are getting? We are getting this 38 and 27, right? This will return 38 and this is containing 27, right? And array will be 38 and 27. Got it? This is the last call. After this it will not be possible, right? This we can't cut more arrays from this, right? This is the last call. The array is this, the midpoint is this, and the basically left and the right pointer is this one. This is the left, this is the right. Got it? After that we are calling the merge arrays for this array, right? And this is the left, this is the right, and this is the mid, right? Got it? Understood this part? Like after this, if we try, it will check this condition. If left is smaller than right, that is not possible, right? So it will return, and again we will be at this call. After this we will be calling this method, right? Again it will check this condition, again it will return. So we will call this merge arrays for this array, and this as the left, this as the left pointer, and this as the right pointer. Understood? This is a bit tricky part once. Okay, let me copy the code. Let me write it first. Okay, this is the two arrays, these are the two arrays. After that, after completion of these arrays, we are calling the one merge method, in which we will be merging the arrays after sorting them, right? So array, left pointer, the mid pointer, the right pointer. So this is the code. Okay, so this is the code. Let's write the example also. Example was 38, 27, 43, 43 and 10. This was the array, right? Now it will go into the loop. The left was at this point, right at this. Okay, now it will calculate the mid. Mid is this, left is 0, right is 0, 1, 2, 3, right, 3, and mid will be 1, right? So this is the initial variables, right? After that it will call this merge sort with what? With left as, let's write this first call. Okay, left will be left only, right, and the right will be mid, correct? Now this is the array 38 and 27. Got it, right? Again it will call the same function. This function will execute again with these configuration, right? Here is the right 38, 27, 43, 10, array as it is, right? Array as it is, left at this, right at mid, this point. Okay, this is left, this is right. For this call I am saying the first call. Again it will execute, it will calculate the mid. What is the mid now? Mid will be 0 only, right? It is 1 divided by 2, it will be 0 only. So here it will be mid. Now again it will call the same function, the second function. Now left is left only. What is right? Right is mid. Mid is what? 0 only, right? Mid, that is 0. So now 38, 27, 43 and 10. Again it will call the same array as it is, left at same index, right as mid. Mid is 0 only, right? 0, left, and this is right. So now we got 38. After this, can we divide it further? No, we can't. So we will move to the next call, that is this one. Okay, this one. Now it will go for the right and divide the right as it is. At the end we will get what? We will get 27, right? 27. Before 27, let's see. It will check for this, right? 38. Can we divide it from the right? No, we can't. Now it will go to this. The stack will be there, right? It will go to this call. When left as at 0 and right is at 1, right? This was the array. Now it will collect the right from this, the right array, right? So we will get 27 from here. Got it? Then when it will complete, at the end we will get 38 and 27, which we can't be divide further, right? So we will be calling this merge, right, after completion of these two methods, right? So we will be putting this left at this index, right at this index, and we will be calling the merge function. We will merge them. After merging we will get 27, 38, right? Understood this point? And when we complete this, it will move further. Now this was completed, right, the first part, and with the second part we got 27. Again it will move up, right? It will move up and it will go to this call. Now it will collect the right part as we collected this left part, and so on. Let me explain it. Okay, once more to you guys. We are having 38, 27, 43, 10, right? How this recursion will work? It will go to the leftmost first. Okay, we are having 38 and 27 here. right? After that we will have 38. Then it will move to the right side. It will now get 27, right? Now it will move above. We will get 43 and 10, right? Again it will call the left side first. We will get 43, then we will get 10, right? This will be the flow. So we are going like this. Okay, so like this. So this is what, this is in order traversal. You will learn this in trees. Okay, we are going to the left first, then we are coming to the right. This is how we wrote the function. First we are completing the left part. This is for the left part. Then we are coming to the right part. When we will complete for the last left and right, then we are calling this function. Okay, we are having this merge function where we are passing the array, the left and the mid, the right, correct? From left to mid, this is the one array. From mid to right, this is the second array, and we need to merge them. Let's write the function for this. Okay, so it will be public static void merge, right? We are having the array. We will be having left side, left pointer, the mid and the right, correct? Now there will be two arrays, right? From left to mid, first array, and from mid plus 1 to right, second array, correct? Let's make the size for this. Let's say n1 will be m minus l plus 1, right? And int n2 will be what? Right minus m, correct? So these are the length of the two arrays. We need to merge them after sorting, right? So let's create the temp arrays for both the left and the right arrays, right? Let's say int left will be equal to new int of size n1, correct? And int right will be of size n2. Got it? After that we will copy the data. Let's say we are having the array. What was the array? Array was, this was the array 38, 27, 43, 10. We are passing this array as it is, right? Now we need to extract the items, the elements for the left and the right, and we can put them, right? So for the left, it will be from left to mid. This is the left and this is the mid also, right? And for the right, this was the element. So we will put that in both the arrays. So what we will do, let's say for loop will be there. This is basically we are checking for the single element. Let's say we will go up, right? In this let's say diagram, when we will come to this or this, like we need to sort them also, right? Sort and merge. At this case, how we can do? We will be using the for loop. For loop, let's say int I equal to 0 till when I less than n1, correct? N1 is the length, and I plus plus. Got it? Now L of I will be equal to array of L plus I, right? What is L? L is the starting point of this array, right? L plus I. Understood why we are doing L plus I? It's I. Because let's say we are checking this array 43 and 10. Then what is the index for this? It will be L starting from here, right? And L plus I. For the next element, it will be like we are traversing the for loop. So when I will come to 1, it should be this element, so it will be L plus 1. Correct? Simple math logic. Okay, so we are copying the elements in this temp arrays, we can say, right? After that, for the second array also, less than what, n2 was the length, and j plus plus, array j will be equal to what is the index now for this? It will be mid plus 1, right? It's starting from m plus 1 plus j. Correct? So we are storing the elements in the left and the right. Now we need to merge them. So I equal to 0, j equal to 0. Now how can we merge them? We will be having one while loop. Let me write the code. K equal to L, starting from L, right? And while loop will be there, and we will be checking what condition. I should be less than n1 and j for n2. J is less than n2, right? We will be comparing the elements. If L of I is what? Let's say it's smaller than equal to R of j, right? In this case, what we need to do, the first element should be for the left, right? Because left is the smallest. So we will be updating our array of k, right? Let me write it. For updating the original array. Okay, so I is for the left array and j is for the right array, and we are comparing the elements, and we are updating the array with the smallest. It will be of I. Correct? And we will do I plus plus, else in the else part, and k also plus plus, or we can do after the if else conditions. Okay, in this, otherwise we will take the element from the right array. Correct? Here it will be j plus plus, after that k plus plus, right? We can also write this k plus plus here also in the if and the else condition, but it's common for the both, so I'm writing it afterwards, right? So now we are comparing the elements from the left and the right arrays, and we are updating the original array. Correct? Now there may be some elements left in the right or the left sub array, right? Anyone should have the array, the elements, right? So we will be simply adding the remaining elements, right? So if I is less than n1, that means there are some elements in the left array, so we can simply add it without any comparison, right? L of I plus plus, k plus plus, right? And same for the right. If j is less than n2, array of k will be equal to right of what? J plus plus, and k plus plus, right? So this is the code. Let's run this. Okay, here we need to return the L, and the last was array dot. What is the count of this? 1 2 3 4 5 6. It will be 5. Okay, it's sorted, right? So what we are doing in this merge thing, see, we are having the left and the mid and the right, let me write it. The array was 38, 27, 43 and 10, right? At the first step, what was the array? What we are basically merging? Left was here, right was here and mid was here, correct? So basically this was the array, correct? Now in the code, what we are doing? We know this left array will be from the left till mid, right? So we are calculating the size for that, right? Understood this part? Size of left array, size of right array. Okay, after that we are making a dummy array. Let's say temp array for both left and the right side, correct? So it will be like this. We are having left, we are having left array as 38, right array as 27, correct? After that, what we are doing? We are simply checking the elements from the right and the left. Okay, whichever is smaller, we are updating the array. Array was 38, 27, 43 and 10, and we are having k as starting index, that is L, starting index of the array, current array, right? So it will be here k. Now we are checking the smaller element and we are updating this array. Array of k, that is this element will be what? Will be the smallest element, right? Either it can be, in this case it's 27, so it will be 27. This element will be 27 now, right? Otherwise this is completed now. Okay, we are left with this array. Now we have the condition for this also, right? We are having this condition, this while loop. What we are checking in this? Basically we are checking the remaining elements, right? And we are updating the array of k. So now we will update this element as the remaining element, that is 38. So we got this part sorted, that is 27 and 38, right? So this is one recursive call. Again it will go up, as you see here. Again this part is sorted now, sorted. It will go to this part and we will sort this part, right? This part will be sorted as the same, right? And then we will sort these two arrays, right? Using recursion. See what we are doing here, we are creating this left and the right array, right? So we were having this 38, 27, 43 and 10, right? So this was the left pointer, this was the right pointer, and this is the mid. So this was the left array, this was the right array. We are just creating the left array, the dummy array and the right array, and we are simply inserting the elements for the same, right? This was the left, we are simply inserting it 38 and here 27. That's what we are doing here. We are inserting li equal to array l plus I, right? L plus I will be what? We are using the loop, right? And L is here. So for 0 it will be here 38, right? Same for the right. What is the time complexity now? It's n log n. Okay, this is the main thing. Now the last is quick sort. I will be explaining the logic, but the code you should try. Okay. So in the quick sort, what we are doing? We will be having one pivot element, right? Pick a pivot element, partition the array such that the left is less than pivot and right is greater than pivot. Okay, basically we need to find the correct position for the pivot element, right? So we have this 5. We can see here after converting, the lesser element should be on the left side, the greater element should be on the right side, right? These all are smaller, these all are greater, correct? So this is the first, after first traversal, and we are taking this array, right? Now we are taking this left array, and same with the right array. We will pick a pivot element in both arrays. In this case we picked 2. Again we will basically insert all the elements, the smaller elements on the left side, the larger element on the right side. Basically recursively function we will be using, right? Recursive function. And again we will do with the left and the right array, the same thing we will do, right? Understood? Choose a pivot element. It can be either middle, last, or random, or the highest element, anything. After that we need to partition the array so that the left should come on the left side. Okay, the basically smaller element should come on the right, left side. The larger element should come on the right side, correct? After that we will recurse same thing on the left array and the right array, correct? This 5 is the correct position for this, right? After that we will apply the recursive function on the left array and the right array, and for this 2 is the correct position, right? And same with this 1 and 3, 4. Got it? Let's say we picked this 5 as the pivot element, right, from this array. Now we need to basically traverse the array and insert all the elements or move all the elements that is smaller from the pivot element to the left side. Got it? We got this 1, 2, 4, 3 on the left side that are smaller than this 5, and the larger element that is 6, 7, 10, 9 on the right side. Got it? After that we get to know that this is the correct position for 5. All elements that are greater are on the right side, that are lesser on the left side, correct? This is the correct position for 5. Again we need to do same thing on this left array and the right array. We will pick a pivot element, let's say 2, and we will move all the smaller elements on the left side, all the larger elements on the right side. Again 43 we will pick a pivot element, let's say 3. We will move all this basically the smaller elements on the right and larger on the left. Okay, same with here. We will pick a pivot element, convert all the or smaller elements on the left side, larger elements on the right side. Got it? Let me show you the code. Here is the main function for the quick sort. Okay, now the first thing is we need to find the index of the pivot element, right? So we will be calling one function partition in which we will be passing the low and the high index, right? So let's check the partition function. In this we can choose the pivot element randomly, anything. It can be low, it can be high, right? So this is the pivot element. After that this is the I will show you. Let's ignore this part. Now we need to traverse, right? We need to traverse and find all the elements that are lesser than the pivot element and move them to the left side, correct? So we are checking, we are starting from the low and we are checking this element with the pivot. If it's smaller, then what we are doing? We are swapping this, right? We are swapping the I that was initially low -1, that is below 0, that is -1 initially. Let's write this initially -1. When we will get this array j less than pivot, then what it will do? It will increase the I, it will be 0. Now we will swap these elements, right? So if I show you, see, initially I was at -1, okay, and j is at this index, the first index, and this was the pivot element. We are checking. Now we need to check these elements 10 and 40. We will compare. This is the pivot element. If this 10 is smaller than the 40, then we need to swap this. Swap what? Swap these elements. Which element? Initially the same element, right? Basically we need to swap with I. Okay, so initially 10 will be there, right? So it will swap 10 with 10. Got it? The next I will come here, right? I will come here because it swapped 10, right? At this time I plus plus I will come to 0. Now j will come to here. Again it will check what? It will check 80 and 40, but 80 is greater, right? So we will ignore this. We will move to the next part. 30. Now it will check 30 and 40. 30 is less, right? 30 is less. We need to swap it. So we will swap these numbers. That is these numbers. Okay. So we will do I plus plus. I will come here, right? I will come here and we will swap this with 80 and 30. So here it will be 80 now, and here it will be what? 30 now. Okay. After that, now I is here. Okay. After that, j, it will compare. Both are basically 90 is greater. It's not smaller, right? So we will ignore this. At the end, we need to change this pivot also, right? Pivot also. We need to swap it this with this. Okay, I plus plus will happen. I will come to here now. It will swap 80 and 40, right? So here 40 will come, here 80 will come. Okay, you can see we are having all the smaller elements from this pivot element on the left side, all the greater elements on the right side. So basically we are having one pivot element and we are checking the numbers. If they are small, then we need to put that on the left side. Okay, this is the left side. I is for the left side, correct? At the end we need to change the position of this pivot element also. With what? With the next position to the last change. Last change was this. The next position will be this one only, right? Basically last with the, this was the last, right? 30 was the last. So 40 should come after this, right? Because others are greater only. So after that, what we are doing, we are swapping this. I explained this part, right? We will do this part till this point. Okay. After that, what we are returning, this is for the pivot element, right? We need to change the pivot position also. After that, we need to return this position, that is the index of the pivot. That means what? That means this index, right? The 40, it's 0 1 2 2. So we will return this, and we can say now the left side is smaller, the right side is greater. That means this 2 is at the correct position, right? So we will recursively call for the smaller also, for this greater also, right? The same function. Again, within this array, we will we will pick a pivot element. Again, we will convert, we will swap all the smaller elements on the left side, right? The same thing we did, we will do for the left side and the right side. So we are returning I plus 1, that is index of pivot, and we can say pivot is at correct position, right? So now if you see here, we are getting this index, right? After that, we are running the same function for the left hand side array and the right hand side array, right? Till pivot element, from low to pivot and from pivot to high. Got it? So in this way we will get the sorted array at the last. What is the time complexity now for this? It's and log n. Okay, right? So let me explain it again to you guys. This is the main function. We are basically calling this partition function, and that we will be returning the index of the pivot element that will be at the correct position, right? We can write here this pivot element is at correct position now, right? So within this partition function, what we are doing, we are setting a pivot element, anything. It can be anything like array of high, low, or random, anything, right? After that, we are running this for loop, and within this, if we are getting some element that is smaller than the pivot element, we need to put it at the left side, right? Because at the left side there should be smaller elements, right? So every smaller element than the pivot element should be at the left hand side. So we are using this I, okay, and if we got the condition true, we will be incrementing I, and we will be swapping that element with the I index. Okay, so this is the swapping logic. Using third element, we are swapping array of I and array of j. Got it? At the end, we need to swap this pivot element also, right? If we like at the last we swapped 30, right? If you see the question, we swapped this 30 at the last. Now 40 should come after this, right? This was I, so we need to swap this also. So we will swap this element with the pivot. We will get 40 here, right? So understood. So we will returning the index of the pivot that is at the correct position, and we can say the left hand side is containing the smaller elements, the right hand side is containing the larger elements, and we will call the recursive function for the left hand side array, and the right hand side array we will perform the same thing. Got it?